Hello everyone, in this last lesson of the unit multiple streams, we're gonna talk about the pinch and the way to calculate the minimum number of heat exchanger, and also about threshold problems. The pinch is a key concept in heat integration, and the best place to see it is at the T versus delta H diagram. The pinch is the enthalpy flow rate, this vertical division, for which the temperature difference between composite curves is minimal. It is. We build composite curves and slide left or right till the minimum approach is met at one point. In this disposition, this horizontal coordinate is the pinch. We will discuss in depth the concept of pinch in its own unit, but for now, what is important to understand is the pinch is mainly a division into group of streams that we will call semi-problems. The core of the concept then is that the pinch divides the stream, the set of streams that form the problem, into groups. One of the streams or parts of the streams above the pinch, and one set of streams or part of streams below the pinch. At this point, we will use the concept of pinch in calculating the minimum number of units or heat exchangers. This is, of course, the minimum number of units needed to make the process work with the minimum heating and cooling. The procedure to calculate it is: first, build the balanced composite curve for a concrete minimum approach and some specifics utility or utility stream. It is for this boiler at 2 bar and this cooling water from this to that temperature. These give us some specific combined composite curves. Then locate the pinch, the hot pinch and the cold pinch, the division for the minimum approach, and count how many streams or parts, including utilities, not only process streams, appear below the pinch and above the pinch. If a stream extends across the pinch, an individual stream extends across the pinch, then it is counted 2 times, one in the above side of the pinch and one in the below part of the pinch. Once that's done, the minimum number of units is easy to calculate. Is the number of stream of part above the pinch minus 1 plus the number of stream of parts below the pinch minus 1. This is a general result that comes from Euler theorem on graphs theory, but as an insight, you can see that if you made a contact and eliminate the needs of one stream, here you made another contact, eliminate the needs of that second stream. You made the third contact, here you eliminate the needs of this stream, and in the last contact, because it is balanced, you eliminate the needs of both streams, then you are finished. The number of contact, the minimum number of contact, is then the number of streams minus 1, and this for every side of the pinch. To finish this lesson and the unit, we're going to talk about threshold problems. This is a special kind of problems. only heating or cooling is required. Here you have a threshold problem requiring just cooling because there are a lot of duty in hot stream and much less in cold stream. And here you have a threshold problem needing only heating. Threshold problems are called so because for a utility there is a minimum approach in temperature where the other utility appear or disappear, a threshold. See that it is well seen in the T versus delta H diagram. Here, for a concrete minimum approach, you need just cooling in this problem. If you increase the minimum approach, you can arrive to a situation where it's just balance in the heating part. And if you cross this minimum approach, you increase a bit the value, then you start having heating. Then there is a threshold that you cross in minimum approach temperature that divides no needing of heating or yes. Depending on the specific problem, normally the minimum approach is maximized or the utility level is minimized. If the minimum approach is maximized, you have a wide gradient for your heat transfer, or if minimized, then the utility level, the cooling, is minimized. Well, we will see it at the design unit, but threshold issues are not very common in industry.